Alright, continuing on, number 64, find the sum of the first 18 terms of the arithmetic sequence. If the first term is 2 and the common difference is 7. Okay, so we just saw in the very last problem in the last video, so if you need to see another example of this, maybe go watch the end of that. But the sum of the first n terms is n, a1 plus an over 2. Okay, so we're going to fill some stuff into this equation, and these equations you should have on your note card. So first of all, I am interested in the sum of 18 terms, like such. And notice the n shows up right away again, so there it is. And I need a1. Well, first term is 2, so that takes care of that. Probably should have done that in blue. So there's the 2. And I know I'm going to add the last term and divide by 2. So the real mystery is, well, what goes here? Well, I need to know the 18th term, because, right, n is 18, so I need the 18th term. Well, A18, I'm going to use the general rule for an arithmetic sequence. It says start with A1, add n minus 1, and again 18 minus 1 because it's the 18th term, times d, and they tell me the difference is 7. So I can get this right away if I understand that I can use that formula. It's 2 plus 17 times 7. So let's see, I'm not sure what 17 times 7 plus 2 is, so I'm going to figure that out with my calculator. 17 times 7 plus 2 is 121. And guess what? 121 is what I need to put here. So let's see. 123 divided by 2 times 18. I will get 1107. 1107. 65, this one's a little bit easier. Find the common difference. Basically, I need to know what do I add each time to get the next one, and hopefully it's not too terribly difficult to see that it's plus 0.2 plus 0.2. So 0.2 is the answer. D equals 0.2. 66, we're going to talk about geometric sequences. It says give the first 4 terms of the geometric sequence where A1 is 3 and R is 2. Well, guess what? Yoink and yoink. You know why I did that? Well, it tells me the first term is 3. And there are only 2 answers where the first term is 3. And really the only thing I need to get this is I need to understand how geometric sequences work. I multiply to get the next term. So I'm looking for one that starts at 3. The next term, if I multiply the first term by 2, I'll get negative 6. Multiply again by negative 2, I'll get 12, and so on. This one right here should be an absolute layup of a problem. Okay? All right. Number 67 and 68, we're going to see some sigma notation. So for this guy, it doesn't really say whether it's arithmetic or geometric, so I think we'll just do this one by hand. So I think the first thing is to notice, excuse me, that I am adding 4 terms together. So I'm going to add 4 things together, and they are going to be defined by, and they use j here, 1/5 to the j. So the first term is 1/5 to the first power. The second one is 1/5 squared. The third one is 1/5 to the third, and the fourth one is 1/5 to the fourth. And again, I know that because it says j, which is the exponent, should go from 1 to 2 to 3 to 4. That's what that means. And so if we all add all that together, I can't do that in my head. So I'm going to do that on my calculator. And when you do this, you want to make sure, I always recommend fractions go in parentheses. And that's exactly how I'm typing it. I know I have to type 1/5 a lot to do this, which is not my favorite thing in the world to do, but it's a small price to pay to get it right. Now the answer I get comes out to a decimal, 0.2496, but by simply hitting math and a fraction, I can get that it is 1/56 out of 625D. Okay, now 68 is going to require just a little bit of explanation, because as I'm recording this, I'm realizing that we did not actually do a problem like 68. What you will notice is that the ending point is infinity. So I'm actually going to sum an infinite number of numbers. And you say, well, if you add an infinite number of things together, won't that just give you infinity? And the answer is not necessarily. Okay, this is some of the things we explore more if you ever take a calculus class. So for our purposes, I'm not going to try to get into all the details. Let me give you what you need to get the problem right on the exam. Okay, I don't want to penalize you for it. The sum of an infinite geometric series is this. It is A1 over 1 minus R. A1 over 1 minus R. Now, if you remember, this right here is a geometric rule. It follows the form A1 R to the n minus 1. So everything I need is there. Okay? And I don't need the n here because I'm summing all of the terms, an infinite number. A1 is right there. It's negative 22 over 1 minus, and R is right there, 5/9. Now again, I got to do a little calculator work here to see what the sum of this, if I add all the terms up, is, but I can do that. Again, watch your parentheses. You can do this in a couple steps if you want to. In fact, I think I'll do the denominator right all by itself here. And again, I'm going to use my, when I do 1 minus 5/9, I'm going to put 5/9 in parentheses. I always like to do my fractions in parentheses. Now, when I do that, I am going to get 0.444 repeating, and that's okay. We can leave that as a decimal for our purposes. I assume the answers will be decimals. If not, we can always convert and check our fractions. But negative 22 divided by 0.4444, lots of fours, is going to give me negative 49.5, and lots of zeros afterwards. So that's a rough approximation, but it gets me pretty close to what I need. Alright, so the next topic here, number 70, we're going to look at some trig stuff. So a photographer points a camera at a window at a nearby building forming a 56-degree angle. Now, drawing pictures here, ladies and gentlemen, is your best friend. So here's Mr. Photographer, and we have a 56-degree angle. Now, at this point, make sure your calculator is in degree mode because we are talking about degrees, not radians. It says the camera is 60 feet from the building, so 60 feet from the building, and I'll draw the building up here if it helps the visual effect. There's my craptacular skyscraper. And I want to know how tall the building is. Well, if we look at what I've got here, I've got an angle, and I know about the adjacent side, and I am interested in the opposite side. And last time I checked, of my three major trig functions, the one that uses the adjacent and the opposite and the adjacent is tangent. So I'm going to say that the tangent of 56 degrees is opposite. Now that's my unknown, so let's just call that x, okay? The building is x height, over my adjacent, which is 60. So I just need to get x by itself. X is being divided by 60. Last time I checked, the opposite of divide by 60 is times 60. So what I'm actually doing on my calculator, these are going to cancel. X is going to be 60 tangent 56. Now again, you want to be in degree mode, and actually I just checked my calculator and it was in radian mode, so good thing I did. So I'm going to do 60 tangent 56 degrees and get approximately 88.95 feet. So x is approximately 88.95. Okay, 71 says, write cosine x is a fraction in lowest terms. Well, cosine is adjacent over hypotenuse. So here's my angle. There's the adjacent. There's the hypotenuse, so it's 24 over 26. Need to simplify it. Great opportunity to just use the fraction button on your calculator. If even if you can do it in your head, I mean, you might as well make sure you get it right. And I'll do that myself just to make sure, and I'll get D, 12 out of 13, which is what I thought it was in my head, but it never hurts to check. Alright, let's finish up the review guide here in page 72. Question is convert 150 degrees to radians. Well, what I want to do to convert to radians, I want to multiply by pi over 180 because there are 180 degrees in pi radians. So I'm going to do 150 times pi over 180. Now again, this formula should probably be on your note card, but I'll have you notice that what I end up doing is canceling degrees with degrees, and I'm just left with radians. Now at this point, I will just take this fraction, 150 over 180, and I'm going to enter that into my calculator, because it is 150 pi over 180. That's just not simplified. There's stuff that can cancel. So I'm going to take the 150 divided by the 180, do the math, the fraction, and that simplifies to 5 over 6, and the pi just comes along for the ride. So 5 pi over 6. Now in problem 73, I'm doing the exact opposite thing. I'm converting to degrees, and so the multiply is exactly the opposite. It's 180 over pi. Again, 180 degrees in pi radians. And I've got 15 pi over 4. Now the key thing here is what should happen is your pi's are probably going to cancel out, leaving 15 times 180 on top and divided by 4. And this is just a graphing calculator problem. 15 times 180 divided by 4 equals 675, whoops, that's a 5, 675 degrees. Okay, 74 says, what is the cosine of 7 pi over 4? Ladies and gentlemen, here's what you need to do. You need to use your calculator, but you must be in radian mode. If you don't do that, you are going to get the wrong answer because it's going to think that's a number of degrees. How do I know it's not a number of degrees? There is not a degree symbol. Also, I see pi. So I am going to enter into my calculator. I'm going to flip it into radian mode right now, and I'm going to back up, and I am going to say cosine of 7 pi over 4. Now, what I end up with is 0.707. So, I'm pretty sure those are out of play. It's not 0 or 1. It's probably one of these, and if you type these in on your calculator, you should also get, this one will give you negative 0.707. This one will give you positive 0.707. So, D is the correct answer. Because my calculator doesn't give me this nice fraction, so I have to do a little work to get that, or to check to make sure the fraction is right. Okay, now if that wasn't enough, 75 flips right back to degrees, so we got to go back to our calculator and flip it back into degree mode, and it simply wants the sine of 305. So enter sine 305, and bingo bango, it is negative 0.819, letter A. Well, that's it. Okay, this has been a long review guide. Hopefully these videos have been helpful, and good luck on the exam.